All right, so if you're looking at the first problem here, it says, which statement best shows the difference between a line and a point? I mean, it's kind of obvious, but like there's a line,
Yeah.
there's a point. So
Yeah, it'd be the point has no dimension, but a line has length has a dimension to measure.
lines extend though infinitely, so you can't actually measure them. A line segment you could um, measure, I guess, depending on that. Um, so let's go through like what it can't be. A line and a point cannot be collinear. So that's not true. They can definitely be collinear. A line has width and depth. So that's not true. A line is just moving on in one direction. So that one is also out. The point has no location. See that's sort of like it is a place. I believe it's one of those undefined terms, but a line can lie on a plane. That is true. See, I'm really bothered by a line has a length as a dimension to measure because it does extend infinitely. You're thinking this one though.
Yeah.
Okay.
Because in the
We have a
first
problem.
lesson, yeah, it kind of talked about the points having no dimension and
Okay.
the
Versus no
point,
location.
yeah,
Okay. Well, that's so it must mean that you can measure portions of the line because
yeah, I think that's what they're kind of trying to get at.
which
Yes.
would be nice if I actually said that. But all right. Well, kind of talked about that one. So if you want to send over another question, we'll take a look.
All right. All right, there we go.
All right, there it is. All right, so here we go. We got is the figure an example of a segment? So a segment is fixed. This is not fixed. It extends off in both directions. So no, it is not a segment. It actually extends infinitely in opposite directions. That's the example of a line. So no, it is not a segment. It has these endpoints or these endpoints, but it extends past each of them.
All right. Let's see. So this is the next question.
All right, got another one here. Take a look at that. Oh boy, okay, a lot here. So this is instructions. That was one of our earliest lessons here. Let me make this a little bigger so we can see it here. All right, so it says Naomi draws a portion of a figure as shown. She wants to construct a line segment through R that makes the same angle with QR as PQ. So basically she wants to copy the angle over here at R. All right, and we have to figure out the next step for this. So let's see here. So again, kind of like we can get rid of some, like you're not using the ruler quite yet. You do use the ruler to connect points. But let's see here. So you would normally swing an arc like that, which is what's already been done from S to T. Okay, and then you would swing the same arc, which is what they've done there. Then you would go to S, point S, and swing an arc at T. So we're looking for something like that. Which what are they trying to show? Okay, so this one, I guess the first one they're trying to show like a ruler connecting, measuring the distance between the arcs. It's definitely not that.
So it's either the second one and the third
Yeah,
one.
so these make sense because they got there. There it is. That's the one. Okay, so this one is showing that it's swinging a little arc there. It's hard to see. That's what we were looking for. We're looking for swinging a little arc there. So just got to take a little time, because then you would come over here and you would copy swinging that little arc, and you would copy the angle like that.
All right. All right, I'm gonna try number 6 because it seems like it's it sounds very similar to the first one, but like I put in the chat.
Here we go. All right, Mike constructed quadrilateral POQS. He used a compass and straight edge to accurately construct a line segment OS. I guess that as shown in the figure below. What could the measure of angle POS and angle TOQ? POS and TOQ. Okay. So the thing that maybe isn't clear is that in a well, I guess I can't assume that. It sure looks like a kite. If it were a kite, we could say that it bisects this angle, which is kind of the only reasonable answer here, which is that this dotted line is not drawn very well. These two angles are the same. So there's kind of
So like if so with that if like for example if you look at the first one, it says that POQ is 50 degrees, so that's saying the whole angle, both sides bisector is that whole thing is 50 degrees, and then half of it is 30, which is
right,
half of
right. And
third half of 50s and 30s.
so
So
the only reasonable one is this
yeah,
last one, but that's not really, I mean, really, that's not, it's a bit of a leap. I mean, it does look that way. I don't know how else you could measure this. You can, for example, trisect an angle. Like if you had a 90-degree angle, you can trisect it, which is, pretty difficult to do, but you can get 330s. But I don't know. Like what I'm seeing here is they're cutting that. Yeah, it looks like they bisected the angle. So it has to be this last one.
got it. All right. Next one's sort of choosing which student steps were correct. Let me put it in the chat.
It is, right? Okay. Oh boy. Um, These ones you really got to look at one-on-one. The figure below shows a partially completed set of steps to construct figure PQRS. So it appears that they're trying to make a parallelogram. So the final is that it should look something like this when it's all done. To do that, you have to copy this angle, which is what they're starting to do. Okay. And so that's the next step we're looking for is kind of like we're looking for at the previous one, is where you fix the compass at L and swing an arc at M. Okay, so so that gets rid of student 2 and student 3.
So, but then student 4 says fixing compass to L and then adjusting the width to point P instead of
Yeah, so
point
that's
M.
where it's wrong. You want it to be you want to fix it at L and swing it to M. So that's why it has to be student
Student
1.
1.
Yeah. So I know this looks really complicated, but if you could just look at the first clause in the answers, you know, fix the compass at L, fix the compass at M. Well, you could. No, you cannot do that. You have to do it at L. So that's how you kind of reduce these answers down to ones that are more meaningful.
All right. Here's number. Let me put this in the chat.
I'm sorry. It does look like I didn't realize you'd sent it. There it is.
Okay, it's
Okay. If I worked for Zoom, I would have all these feature requests that is a real user. Okay. Architect plans to make a drawing of the room of a house. Nobody does that now. We all use computer aided design software. The segment LM represents the ceiling of the room. He wants to construct a line passing through Q perpendicular to side LM to represent the wall of the room. So the goal here, here's L, here's Q, it's to draw a perfectly 90-degree meet at 90 degrees. And here's how you can do that. You first, well, the traditional way to do this is to go to point L, fix the compass at L, and you swing an arc, okay? Then you go to each of those and you swing an arc, and then you go to the other one, fix it and swing an arc. And then you connect with a straight edge like that. All right, so what it appears, let's see. Fix the compass at Q, fix the compass at L. without changing the width and position, draw an arc between L and M. Without changing the width of the compass, place the compass at M and draw an arc. Okay. So like normally this would be the first step and this would be the second step. Above the line. Why you wouldn't, and you do it on, you can also do it on, you can also, the stuff that's down here at 3, you can do up here at 4 as well. But you don't need to because you already have the point. Fix the compass at Q and draw an arc below the line. Fix the compass at L. Draw an arc between L and M. So I think this is the one because like I said, I think they're showing 1, even though the compass is in a weird spot. I think they're showing 2 is the next one here. Like I think the next thing they're trying to show is that.
God. All right. Now number 9, tasking.
All right, there it is. All right. Ooh, we had a problem like this at some point. And I want to say it's an equilateral triangle just from memory. And I think the reason is that these are radii, and then you can connect another radii here, and then this is a radii. So you actually get 2 equilateral triangles, but maybe take a look back at your notes. One of the things I'm noticing is these numbers might be good if you're snipping these pictures into a document, just to put the point, 0.1.03
Yeah,
MC.
because I think that
That
points to like a certain
that's
lesson.
Yeah, and that's searchable for you as well, to find.
Yeah, because in the videos they go around and put like the 6 arcs on the circle for equilateral triangle.
Yeah, so I mean, this is reasonable. Like if you draw a radius and a radius, I don't know what else you can get. I mean, because you can't get a square. You can get yeah. So I guess I would say that that's it looks like an equilateral triangle, 2 of them.
All right. Right, that's in the chat.
Right. Save. All right. More constructions. Okay. All right. So when constructing an inscribed regular hexagon, so that here's what that means. Here's a circle, and the word inscribed means that it's inside. You can just think of the word inside like that. Are you driving yet?
Joe,
Or you're not driving yet. Or
no,
you
no,
said
no.
you're ninth grade. Okay. Stop signs are octagons, not hexagons. Sometimes there's some confusion on that. So you can do this. Now, we kind of already mentioned this. There are six. There are six equilateral triangles inside a hexagon.
Mhm.
Okay. So um, when constructing the six arcs, now if we go back to the previous problem, what they're saying is they've made another arc and another arc down there. And so you can imagine if you've got the arc, those arcs there, you can sit there and connect like that. Does not to scale. Okay, that gives you those, which is not what we want. Okay, so you have to be careful or not to actually do that. You have more. So you actually end up connecting all the all the all of those and the diagonals to get them. So connect every intersection of an arc and the circle with a segment. So that's what we did here. We connected every intersection because there's an arc, 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 and we connected every intersection along the outside. So it's not every other. Well, connect. Okay, so you do eventually connect the intersections of the diameters. You do eventually go this way and get these, but I don't think that's next. I wouldn't say you go. So you might want to look at your notes on this because it's one or the other. Connect the intersections of the diameters and the circle. Connect every intersection of an arc with the circle segment. So the choices are, we'll just draw them again here. So you got that one, that one, that one, that one, that one, and that one. Sometimes you got to draw them all out. So the connect every intersection of the diameters and the circle with a segment. So it's like connecting, doing that, which that should go through the center, or connecting these. And I actually just don't know. So let me, because like it's like you got to do both. So I don't know why the order matters, but according to this, it does. Do you have any notes on this? If not, if
Yes.
not, I'll look here as well.
See.
Inscribed, regular, hexagon, order. Okay, so I'm seeing that you connect you do this one first, which is the every intersection.
Yeah, yeah. It's like you have to mark each
So
intersection.
right, so actually, so now that makes sense because this doesn't give you, I'm sorry, I was confusing too. This gives you the hexagon. That's what we're looking for. I got so down in the weeds of this problem that I forgot. We want the hexagon. We don't care about the triangles. That's why this third one is the right answer.
Yeah, got it. All right, so I think I put adjacent for this one before, but it's just asking like what the relationship is between these two angles. Let me put it in the chat.
This,
Yeah, it's in the
right, so I don't actually remember this problem, but let's take a look here. Which of the following explains the relationship between angles A and B? Huh, I don't see A. You? Am I missing something? I mean, little a is there, but
oh no, as in like the 90-degree angles A and B that are there.
well, it should be lowercase a and lowercase b then. Like if it's truly meaning that, and if this
Yeah, I
is
think
truly
that's what they
representing
meant.
if this is truly representing the coordinate plane, then they are both 90 degrees. Now, are they adjacent angles? Yes. Corresponding? No, that's parallel lines. Complementary angles? No, they add to 90. And vertical angles? No, those are ending at an X. So adjacent means next to. You'll see that later in the course if you do some trigonometry.
Got it. All right. Let me put the for the screen to pump up. Let me take a screenshot again. Like, oh, there it is now.
All right, there it is. Okay, this looks somewhat familiar, meaning I think we've done something like this. Don't know if it's exactly this. So which statement justifies what measure y angle DBC? So D to B to C. So this one right here, that's the one we're interested. Measures 40, given angles ABD and DBC are complementary. Well, that's saying that 50 plus 40 equals 90 because they are complementary. So we're looking for something that says that the two angle measures must add up to 90 degrees. Looks like that one there.
All right. Got it. Yeah. me just get a screenshot of the next question. Okay, I'm gonna go ahead and try this. All right, so I'm
Okay.
gonna see if we got the correct answer.
Yeah, sounds good. I like that you want to work this one out on your own. It's awesome. Let's see here.
All right, I got x equals 7.
Okay. So the check, and this is check here is that this angle is congruent to this angle by vertical angles, congruent to this angle by alternate interior angles, congruent to this angle by vertical angles, or you could go corresponding R to here. So you set them equal. And then is 15 times 7 plus 2 equal to 135? And it is.
All right, perfect.
Very good.
All right. Now this one's more proving it with the theorems. This-
Right, there it is. Save that.
all right, yeah, this is in the chat.
Got it. Did open up there. Oh boy. Oh my gosh. Okay. Well, so okay, we had a problem like this. So prove angle J and L. So where is J and L? J and L is right there. Is congruent to HMN, which is right there. What type of angles are they? Are they alternate interior, corresponding, vertical, or same side interior? Do you remember that from your notes or from like you don't need to read all this. I mean, that is the proof, but what are they? Are they, which of these
It's not.
four?
It's definitely not vertical angles,
I agree. That's good strategies to get a get rid of some that
but they're both not interior angles either.
so interior means they're both in this region, so they're not same side interior.
I would think they're corresponding angles.
They are corresponding. Very good. Because alternate interior means that, and generally it's not drawn this way, but this and this would be alternate interior. They have to alternate over the transversal
Got it. And in this one, the one has to use a 2-column So let me put that in the chat.
And again, this I recall us having exactly this question, or if it didn't ask for corresponding, it might have been alternate interior. Like this is a really similar question, something you've seen before. Okay, there we go. He's got another one in the chat. I like it. All right. Let's do a copy here. Okay. We got JK is parallel to LM. So all the stuff we just talked about in the previous problem, alternate interior, corresponding, same side, they all are true. We're looking for statement 4. Okay, so you just got to follow like that's you don't need to know the givens, or I'm sorry, you don't need to know the justifications for 2 and 3. You just need to know what's happening. So 1 is congruent to 4, 4 is congruent to 8. That's the whole if A equals B and B equals C, then A equals C. So number 4 is the transitive property. Now, where we ran into issues yesterday, and this is my fault, is if it says A equals B and A equals C, notice the order is slightly different than B
Yeah,
equals C. That is substitution.
got
But it has to be this path for transitive, and then this path for substitution.
it. All right, so when it goes, so the one that I got wrong for number 7. No,
There's one we got to go back up and look at.
yes,
This
I
one here.
submitted it, and then we got one wrong.
So students, so what did it tell you which one is correct?
Student 2.
All right. So okay, let me re-grab this and let's maybe talk about it. So like what is normal? Normal is because you want to go to L and swing an arc at M like that's the normal approach. Now, if you swing the arc, I'll do it in green, the way it's describing here in 2, where you fix it at M and swing it at L, that's fine. You just have to flip it and you still swing this. So what I was looking for, and that it's because we didn't read it further, and that's my fault. That's not you. It's me just not wanting to read the rest of the problem because there's a lot of words. But we should have read it. We should have read it. So it could have been you can swing it either direction here, but when you get to N, you have to swing it up here. Like that's the missing thing, because then you can draw this one right there and get that, and then you can similarly well, once you copied the angle, you can then swing an arc, and then connect those like that.
Got it.
All right, so I do apologize. We need to just read them a little more closely.
All right. Um, so now there is some things that I'd like to maybe like one more thing that we could review before.
We got 5-6 minutes, whatever you'd
Yeah.
like to do.
I think we should review like here 1 second. Let me just take a look at this. All right. So I think one lesson to go over a little bit more maybe it might be like the advanced constructions lesson.
Sure, sure.
That's the 01.03, kind of like going over that a little bit more. Um, so here we go back to there. The first one is we'll start off with constructing parallel lines or constructing and
Sure.
copying parallel lines.
I can also show you any of the constructions on here if you'd like. I think that would help.
Yeah, that might help a little bit. Yeah.
Do you want me to
But
just pick some, or do you have some
yeah,
specifically you
maybe
want to do?
we'll start with the constructing polygons inscribed in circles,
Okay,
like the
let's.
equilateral triangle, the square, and the regular hexagon.
Okay, so hmm, yeah, so the cert. Let's do the triangle one because they don't really show you how to do that. They always give it kind of to you mid thing there. So here is a circle, sort of, and then you have to have the center. So you've constructed it from there. Like you create a point. So that's the first thing you do. The second thing is you draw this circle. Okay. Then you pick another point, okay, on the circle. It doesn't really matter where it is, but roughly it is roughly there. And then you swing another circle. So that's three. You swing another circle. Let me copy this. And we go up. Go. So you swing another circle like that. So then you have this point and this point. Okay. And now if you use a straight edge, so that's four, use a straight edge, you can use your ruler there. That's five. In any order here, that's six, and that's seven. So the just keep in mind, like imagine you're swinging the full thing to get that.
Got it.
All right. Any questions on that?
Not really. I think I get it now. Yeah.
So this leads to the hexagon. I mean, you're repeating a lot of the same stuff. So you have the circle, you draw the circle. That's one. That's two. You draw the circle. Then you really um and then I mean, I don't think it really matters, but it's just like before, you have another point here. Call that three, and then you grab that other circle. So this time I'm just going to show the arcs. So you swing an arc up here, and an arc down here that mimics the the radius. Like these are all from you swing the radius, you swing the radius, swing the radius, and then you get those. Now you got to come the other direction. So let's go four, five, and then you come over here. Okay. And you get this point from you can just draw a straight edge through there. If you have 2 points, they're going to be collinear. And then you do the same thing. You swing the arc, and now you got it. You just connect the lines with the ruler, or the points with the ruler.
Got it.
Now the square is a little bit more difficult. Whoa, that's not good. Okay, so there's the square, um, or there's the circle. So first thing I'm going to do is you can just draw a straight line, or you just draw a line. It doesn't matter, because you can always rotate it. But let me actually do this correctly with a line. Some sort of a line like that. Maybe move down a little bit. Never mind. Okay, so I know it's kind of down, but it doesn't really matter. Now you can bisect, not bisect. You can create a perpendicular to the line. So to do that, you swing an arc, So let's go 1, 2, and then you come to each of these points and you swing an arc here and here. And then you do the same thing here and here, and that gives you perpendicular. Draw that. So that gives you a perpendicular roughly. So that's 90 degrees. Okay, now why would you do that? Because you really need to bisect. You need to bisect these, or you can just connect right here and get a square. That's one way to do it. You get a perfect square like that. Now, if you want the one that looked more traditional, which is the one that's got the endpoints here in red, you have to bisect these angles. So you arc, 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 and you repeat, and then you get those lines there.
Yeah, because I think
And then
what I thought at first, like to draw when you're connecting the points between like to make the original, like the first one on the sign red, I thought you had to draw the like line through the arc points, not the,
there's more than one way to do it. I'll just say that. So, if you
yeah,
get a question on this, we'll go through the answers, and I wish it was free response because then you could have a little more flexibility. But all right, well, we're gonna stop right there for today. Good job,
all right,
Karthik.
yeah.